Hello everyone, today I am back again with a lecture on Mohr Circle. So now comes what is a Mohr Circle and why Mohr Circle is being used. Okay, so the Mohr Circle is a circle that has been used for the determination of stresses on an oblique section, and Mohr Circle is generally a graphical method to determine the stresses. Okay, so for explaining this Mohr Circle, let me take the one example so that I can explain it to you, and I will be solving this example both analytically and graphically. Okay, so here is the question. At a point in a rectangular block of an elastic material under strain, there is a tensile stress of 50 megapascal on one plane and a compression stress of 30 megapascal on a plane at right angles. These stresses are accompanied by a shearing stress of 30 megapascal. The shear stresses acts on a plane carrying tensile stress in such a way that it tends to rotate the block anti-clockwise. Sketch the block with system of stresses and determine analytically or graphically. Number A, the magnitude of the principal stresses. Number B, the direction of the principal planes. Number C, the magnitude of the greatest shear stress. Now let's come to the solution. So refer the figure below for the rectangular block with given system of stresses. This is the figure that has been talked about. Here it is a rectangular block with sigma x equal to 50 megapascal on both sides, and sigma y is 30 megapascal, and tau is given as 30 megapascal. Okay, so first let us solve by analytical method. For the given loading system, the principal stresses are given by P1, P2 is equal to sigma x plus sigma y by 2 plus minus square root of sigma x minus sigma y by 2 whole square plus tau square. As we have seen from the question that sigma x value is given as 30 and sigma y will be minus 30. Okay, by 2 plus minus, and we put the values of sigma x and sigma y respectively, and also the value of tau, and after calculation we have received 10 plus minus 50. Therefore, measure principal stress P1 will be 10 plus 50 equal to 60 megapascal, which will be a tensile one, and minor principal stress P2 will be 10 minus 50 equal to minus 40 megapascal, which will be a compressive one. So the position of principal planes is worked out from the relation tan twice theta p equal to twice tau divided by sigma x minus sigma y. We have all the values. We put the values of tau, sigma x and sigma y, and after calculation we have received the value as 0.75. That gives twice theta p equal to 36.87 degree or 216.87 degree. So from there we calculate the value of theta p1 is equal to 18.43 degree, and the value of theta p2 will be 108.43 degree. So now let's calculate maximum shear stress, that is sigma p max, which will be equal to P1 minus P2 divided by 2. We put the values of P1 and P2, which will be minus 40, so the value comes out as 50 megapascal. Angular position of planes carrying maximum shear stress are theta s1, which will be equal to theta p1 that we have calculated from here, plus 45 will be equal to 63.43 degree, and theta s2 will be equal to theta p2, this value plus 45 will be equal to 153.43 degree. So these are the values that we have received through analytical method. Now let's move on to graphical method, that is Mohr circle method. Okay, so here is the Mohr circle that we have drawn by taking a scale of 1 mm equal to 10 megapascal. Okay, so this is the x-axis, this is the y-axis, and this is the circle we have drawn. So let me explain this first. Okay, I will mention the steps also in this video. So first, draw the x-axis and y-axis meeting at the point O, this point. Okay, then with reference to point O, measure OA equal to sigma x is equal to 50 megapascal. Okay, and OB equal to sigma y. Okay, OB, this one will be sigma y, it will be equal to 30 megapascal as given in the question, and this we have to consider in some suitable scale. You can take any type of scale, any scale you can take, but in this diagram I have considered 1 mm equal to 10 megapascal. Okay, so for 50 megapascal it will be 5 mm, and this for 3, this one will be 3 centimeter. Okay, so OA and OB are taken on opposite sides as the stresses are of opposite nature. That's why we have taken this as in opposite sides. Okay, next draw AE and BF. AE, this point, AE, and this point line. Okay, BF perpendicular to AB, this one AB. Okay, and cut off AE equal to BF equal to tau equal to 30 megapascal. Okay, 30 megapascal, tau, the value of tau. So the anticlockwise shear stress as at sigma x is positive and is taken above the x-axis, this one, x-axis. AE, the clockwise shear stress as at sigma y is negative, this one, and is taken below the x-axis. Okay, so now next join EF and the point C. Next join EF with respect to point C, where the line EF meets the x-axis is the center of Mohr circle. This point will be the center of the circle that we want to draw, with C as center and CE or CF as radius. Okay, we need to draw a circle which would pass through points E and F by taking this radius. Okay, so with the help of this radius we draw this circle and we received this circle. Okay, after that we have mentioned the points L, here we have mentioned the points M. Okay, so now from I have mentioned the steps in written the steps. If you want, you can go ahead with this later on also. Okay, I have mentioned the 4 steps how to draw the Mohr circle. So now from the stress diagram, that is Mohr circle, maximum principal stress P1 will be equal to OL, which will be equal to 6 mm. With the help of scale we have received this as 6 mm, and it will be equal to 60 megapascal, because we have taken 1 mm equal to 10 megapascal. So 6 mm will be 6 into 10 equal to 60 megapascal, and minimum principal stress P2 will be OM, which we get from the diagram, and we receive this as 40 megapascal. Next, orientation of principal planes twice theta P will be 37 degree and 217 degree. Therefore theta P1 will be 18.5 degree and theta P2 will be 108.5 degree. These angles we need to measure from the Mohr circle that we have drawn. Next, we have to find maximum shear stress sigma T max, which is equal to Cn, the line Cn, and it will be 5 mm. We received this after measurement. We have received this as 5 mm, and so it will be come out as 50 megapascal. Okay, so I hope this analytical and graphical method is clear. If you want, you can go through the steps. I have written in details, elaborately in the steps of how to draw a Mohr circle. Okay, so with this we have come to the end of this lecture on Mohr circle. Thank you everyone.